Hello humans, welcome back to the Let's Learn Python series here on Code with Connor. This is Unit 1, topic number 3, and yeah, we're going to get into it. So we're going to start off by looking at the challenge from the last lesson. We had a string for each of the pieces that we wanted to put into the Mad Lib. So I had a string word 1, a string word 2, word 3, and those were the variable names that I chose for these strings. And then we have the literal quotation marks, and then inside of them, we have the characters for the word. Now, I chose these words, Harry book ran slowly. You might have chose others. The Mad Lib that I linked in the description had this exact order, adjective, noun, verb, past tense, adverb, adjective, and so on. So I just kind of made a little comment to remind me what I was supposed to be entering, and then I went through and I entered one of each. Once those were filled in, it was all about the print statement. That's what the real challenge was. So let's have a look at it. So you'll see I started my print statement with my parentheses and my triple quotation marks. And then I started here. Today I went to the zoo, I saw on, and then I closed the triple quotes. That ends that string. The plus sign prepares to concatenate. You'll notice I didn't use the str, the str function, because I already have a string. Word 1 is of type string. So I concatenate word 1, then I just put a space, and I use single quotes for that. You could use triple if you wanted to. There was no need. I didn't need any spacing in there like enters and formatting, so I just use a single set of quotes with a space in between. Then I concatenated the next word. Then I reopened my triple quotes. Again, don't put the plus sign at the end of the line. It causes problems. And then we continue with the text from the Mad Lib. Jumping up and down in its tree, period, he, and then end the quotes. Concatenate the next word, a space, and the next word. Back into the triple quotes through the large tunnel that led to its, end it. Variable, space, variable, back into the triple quotes. I got some peanuts and passed them through the cage to a gigantic gray, back to the variables, back to the literal string, and so on all the way to the end. We end it with the triple quotes and the parentheses. So this was our hard-coded Mad Lib. Now if we run this, okay, I got my font a little bit bigger. I found it was a little hard to read in the last video, so I'll scroll it. And you can see it just prints it out. You can see our words that were stored as strings are there, printed out, right? A Harry book. And so it's working exactly as we intended it to work, which is great. So that was our challenge from the last lesson, which was the hard-coded Mad Lib. Now we're going to jump in and we're going to look at Unit 1, topic number 3. In this one, we're going to look at console programs, math in Python. We're going to talk about randoms, and then we're going to talk about user input so we can start to have that interactivity piece. Kicking it off is console programs. So what is a console program? Well, everything that we've been running in Windows PowerShell is an example of a console program. These are programs that only interact using input and output via this text-based interface of the command prompt or the PowerShell or the terminal window, etc. In 2020, these are not programs that the typical user is ever going to interact with in their day-to-day use of a computer. If you start to get into do special things like you want to run a RAM diagnostic or whatever, you might have had some experience with this. If you're ancient like me, you probably remember the days when there was an entire command line operating system called DOS, and we used to use that. So we have some experience with this where other people might not. So console programs are great for this learning to code piece, but they're also really useful for like background scripts. You might have noticed sometime when you're installing software on your computer, a little black command prompt window might pop up, see a bunch of text scrolling through the screen, and then quickly disappear. That's because there's a script running that's doing things like unpacking files or moving things or assigning Windows registry values or whatever in the background. Those are all little scripts that are running as part of an installation of a piece of software. And a lot of times those kinds of things can be written as console programs in a various number of languages, Python being one of them. So these console programs are a great way for us to learn. They allow that little bit of interactivity through user input and printing things out to the screen using text. You can get a little bit more creative with visuals using things like ASCII art and special Unicode characters and stuff like that. But the goal is not graphics here. The goal is function and understanding these underlying principles of programming. We'll touch on like turtle graphics a little bit, which allow like very, very minimal graphic interaction, but they're not anything fancy. And then if you want to get further, you can get into Pygame and whatever, but if your goal is graphics, you're probably not going to be living your life in Python for very long. You're going to move on to other programming languages. You're going to be working in Unity or other things like that, where graphics are really at the core of those languages. So that's what I mean when I talk about console programs. So the first thing we're going to code today, we're going to talk about math. So there's a couple of topics when we look at math in Python that we need to hit on. The first is things like basic order of operations using hard-coded numerical values or variables. Doesn't really matter. So for the purposes of this, we'll create 3 variables. We'll make an x, y, and z, and we'll make 2 of them an int and 1 of them a float. So I have x equals 5, y equals 10, and z equals 0.5. So these are going to be my variables. So let's do some math. Now we can do math directly in a print statement. Because they're all numerical values, it will know to do a numerical operation. So let's try that. What would happen if I do a print x plus y plus z? Remember, we typically saw plus being a concatenation. And we had a type mismatch error last time when we tried to concatenate a string with an integer. So I wonder what's going to happen when we do this. I don't know. Let's try it. Save. We run it, and it gives us the number. It didn't give us a type mismatch error. It actually did the math. And the reason for that is pretty straightforward. The reason for that really is just because there is no string at the beginning of the print statement that it's trying to concatenate to. It knows how to do math on numbers. And if everything that we're trying to add or do math on is a number, no problem at all. But if one of them is a string, it's like, wait, what do you want me to do here? Do you want me to add the string character values? Or am I concatenating? Like, it becomes confused as to how do I handle the mismatch of types? Where all of these are numerical values, it's perfectly comfortable doing the math and then printing that result to the screen as characters. And this math doesn't have to just be addition. We could put a times operator in here. Standard order of operation rules are going to apply. It's going to do multiplication and division as a higher priority than addition and subtraction. So it's going to do y times z, which is 10 times 0.5, which is 5. And then it's going to add it to 5. So it should print 10. Let's test it. And we get 10.0. Now the 0.0 is interesting. So it is just 10, but the thing is that 10 is no longer an integer. As soon as we brought in the float to the math operator, we now have a float value that we're dealing with. And a float value is going to have a decimal piece. So that decimal piece in this case is a 0.0. So it's going to be 10.0. And this doesn't seem important right now, but when we start looking at division, that's when this starts to seem more important. Now you can also use brackets to change order of operations. Again, nothing different than your middle school algebra here or middle school order of operations. Brackets come first. That's going to force the addition to happen first. Then it's going to times. Still going to be a float. Okay. We run it. We're good. If we were to try to bring a string into the mix, so if we were to try to do something like x plus y plus z equals and kind of make it look like a math equation, then we would have to bring in the str, because now I want it to do all the math, and it's going to do it. It's going to still add up these numbers right here, and then it's going to convert the answer to a string to allow it to concatenate it to the rest of the values. So if I save that and run it, you can see it does x plus y plus z equals. That's all just that little string, and then 15.5 came from doing the actual math equation. So you can kind of see how that works with concatenation. All order of operations apply. We'll hit on a couple of quick math operators that maybe you're not familiar with. Let's get rid of that, and let's just do first squaring or raising something to a power. So in Python, this is pretty easy. You can do this with double times operator. So if I do something like x double times 2, that's x squared. So in that case, 5 squared should be 25. Let's save and run. 25. So we can do that for power-based operations, so base to the exponent. We can use that double times operator. The one thing we really need to spend a minute talking about is division and what's called modulus. First things first, let's look at a simple division. Y divided by x. Pretty straightforward, right? Y is 10, x is 5. 10 divided by 5 should be 2. They're both integers, so the answer should be an integer. It's 2.0. What happens if it is not evenly divisible? So if x was now 3, let's run this and let's see what happens. It will keep and convert to a float. Now this is great that Python does this. A lot of programming languages do not do this. A lot of programming languages, when they're dividing two integers, will give the answer as an integer, which means they won't give you that decimal piece. They would only give you the integer piece. Now Python's great. If you wanted to force it to behave in a way that's a bit more reminiscent of some other languages, you could wrap it into an int function, which is going to force it to treat it like an integer. And you'll see that gives me that result of just 3, which we all know 10 divided by 3 is not 3. But sometimes, and in a lot of programming languages, if 10 and 3 are both integers, it's going to do that. Okay, so that's great, and we should talk about that. The last one we want to talk about is something called modulus. So it's a percent symbol operator. So y percent 3. This is a modulus operator. And what this says is it says do y divided by 3 and then take the remainder. So when you do 10 divided by 3, the answer is 3. That's the whole number answer. So we're going to chuck that to the side. We're going to look at the remainder. So after you remove 3 3s from 10, which is 3 3s is 9, how many values do you have left? We have 1 left. So the remainder is actually 1. So if I do y percent 3, the answer of that operation is going to be 1. Okay, if you think of it in terms of fractions, when you do 10 divided by 3, the answer is 3 1/3. It's that 1/3, that 1 on the numerator of the remainder that we're looking for when we look at doing the modulus operation. So where is this powerful? Well, I think the best place for this is when we're looking at even versus odd. And that's doing a percent 2 operator. So later in the code, we're going to look at doing if statements. And a lot of times looking at whether something is even or odd can give us kind of a neat way to do a quick flag check, to do a lot of things. Let's just say for a second that y was equal to 11, and I do y percent 2. Well, anything that's odd is going to have a remainder of 1 when you try to divide by 2. Anything that's even is going to have a remainder of 0 when you try to divide it by 2. So let's run this, and I should get 1. Beautiful. If I were to change y to an even number, say 4, and I run it again, I get 0. So this is that modulus operator that we can use to determine whether something is or is not evenly divisible by another number. So if it is evenly divisible, the modulus operator will give 0. If it's not evenly divisible, then the modulus operator is going to give some value in between 0 and the actual divisor. So that's where the modulus comes in. Really, really cool little math tool. All right, that's the basics of math. Now be aware of things like concatenating the strings in the math. Be aware of integers and floats and how those might interact when you're working with your coding stuff. The next topic we're going to look at is randoms. All right, now randoms is kind of an interesting topic in a lot of different ways, but that's what we're going to jump off to next. In randoms, we get to do the first import of a library. Now, before we do that, what's a library? Well, the thing about programming languages is they don't actually expect you to write every single line of code yourself. There is a lot of code already written, sometimes by the developers of the languages themselves. So in the example of Java, there is a massive amount of existing classes and libraries in the Java world that have been written by Oracle or Sun Microsystems. In the world of Python, there's all kinds of existing libraries written by Python. Then we get into a lot of libraries that are actually user created or other, created outside of the realm of the company that made the language, but they've become kind of sanctioned or approved by the language as these wonderful third-party libraries. So there's all kinds of these existing code bases out there that we can use in our code to kind of make things a little easier for us. One example of those is random. Anytime you're importing libraries, you should do it at the top of your file. It looks like this: import, and then the name of the library. Now, random is a built-in library with Python, so I don't need to go and download this library from a website or using pip or using some other software. As soon as I installed Python 3 on my computer, this library is already accessible to me. And there's a whole bunch of those. And you can look them up. I'll post a link in the description that lists the libraries available with Python 3. So you can have a look around. Just don't fall too deep down the rabbit hole. When we talk about random numbers in a basic introductory programming course, it's important that we recognize that what we call random is not really random. Now, I'm not going to get into the high-level reasons behind this in terms of pseudo-random versus random and where these numbers are seeded and generated. You want to read about that, you can go read about that forever. There is so much out there about the seeds of these random values. And there's places where random really matters, and there's places where it really doesn't. If you're creating a simple dice game that's not going to be, billions of dollars on the line, you probably don't care if your 1 to 6 roll is pseudo-random or random. So now that we have the library there, now you can go look online at some different functions within this library that we can use, but I'm just going to talk about one function, which is the randint function. And it's great for things like dice rolls, random choices, things like that. It's perfect for what we need. So import random, that's great. So we're going to call a function called random.randint. Now, a couple of things about this function. We're going to go yell at this function and we're going to say, hey, give me a random integer. And it's going to yell back an answer. So we need to store that answer in a variable. So I'm just going to do x equals. Okay, maybe not the best variable name choice, but it's fine. So x is a variable that I've created is going to be equal to what I get back from this call to randint. Now, randint requires me to give it requires a min and a max. So it requires the left and the right bounds of that random. So let's say I wanted to roll a dice. So 1 to 6, right? And then I want to print this out to my screen. Print x. So this is going to, when my code runs, it's going to import the random library. It's going to use the random library to generate a random integer from 1 to 6. It's going to store that value in x. And then I'm going to print the value of x to the screen. Pretty straightforward program. Let's save it and run it. 2. Okay, let's run it again. 6, 1, 5, 4. Get the idea? It is generating a random number from 1 to 6, and then it is printing that number out to the screen. It is storing it in a variable, which is important. Now, I could just wrap the random.randint in a print statement, but a lot of times it's important that we recognize that calling a function like randint is giving us something back. And we're going to do a whole section on this in our functions unit, but we need to handle that in some way. And most of the time in our code, we're not just going to want to print it. We're going to want to do background things with that value outside of just printing it to the display. So that's why I like to store it in a variable, just to build those habits. Okay, so this is the random integer function. It's great. There are other more complex functions around randoms like seeds, etc. And feel free to do some reading on that. Again, this is an introductory Python course. My goal with this is for you to understand the core concepts. So these are inclusive values, 1 and 6. They're going to give us a random in that range. Now you can then manipulate that random outside of that range if you wanted to. You can do math on x for some reason if that was within your nature. Once you have the value, you have it. But you have to call randint again each time you want a new random number. Okay, you can't just call x again. X is going to just be the last random that it generated. So you might need to recall randint if you want to get another random integer, for example. All right, that wraps up randoms. Next up, we're going to look at user input. So user input is going to provide that little piece of interactivity with our console program. And this is one of those things where, yeah, people make interactive console programs for some purposes, like a RAM diagnostic program or whatever, might have some basic, user interaction over the command line. But, most of the time, beyond the scope of this course and learning your first programming language, you're probably not going to do a lot of user interactivity within console unless you're doing debugging and stuff like that. You're going to be in a graphical interface because that's where we are in 2020. You're writing apps, you're using graphical interface, using, touch interactions and hotspots, clickable values, all that kind of stuff, gesture controls. You're not using typing in a black or a blue console. But for the sake of what we're trying to learn, it is perfect. So user input, we don't need to bring in any libraries. Again, similar to randint, when we use this built-in input function in Python, it's going to give us a value back. One of the most common things I see when people are learning this is they'll do something like this. Input, enter your name. Cool. That's awesome. You use an input function. It's going to print to the screen, enter your name, and it's going to give the user the opportunity to type something and hit enter. And then nothing's going to happen because they answered and you weren't listening for the answer. It would be the equivalent of greeting someone face to face and going, hey, what's your name? And then turning around and walking out of the room. It makes no sense whatsoever. We need to listen for that response. So we need to create a variable. We need to store the answer from the user. And then we can use that answer in all kinds of places. We could just do a simple print statement where we greet them. I print nice to meet you, comma, a space, and then I'm going to print the name that they just gave me. Right? The computer's now sentient. It's talking to you. This input brings in a string value, which I store in a variable called name, and then I use that variable called name. Let's run it. Enter your name. And notice it's waiting. The cursor is blinking. It's like, what do I do? Right? So my name is Adam Connor. And I hit enter. Nice to meet you. Adam Connor. It stored that value from the user input in a variable and then brought in that variable in a print statement. Now, you don't have to just bring it in a print statement. You could bring it in all kinds of places in your code, right? It could be stored for later to show up with a profile or whatever. But getting that value is great, but you need to store it somewhere. And that's why we talk about variables before we talk about input, because getting that answer from the user is important. Now that's going to bring in a string. The input function by default brings in a string. If I wanted the user's age, I could do something like this. Now let's say I wanted to know how many years until this person was 55. So traditional retirement age, probably not accurate in 2020, but whatever. Okay, I keep saying 2020. It's 2021. It's fine. I'm just stuck in 2020 like so many people. All right, so let's say I wanted to know that. Time until retirement equals 55 minus age. Print time until retirement. I'm going to ask the user for their name, store it in name. I'm going to ask the user for their age, I'm going to store it in age. I'm going to do some math. Time until retirement equals 55 minus age. I'm going to print that. There's going to be an error. Let's see it. Enter your name. Adam. Enter your age. 37. Uh-oh. I got a runtime error. In the middle of interacting with my program, I got an error. I got a type error. Unsupported operand for type string and integer. Ooh. Okay. Okay. All right. Let's go back to the code. Right here. Line number 13. Okay. Hop over. Line 13 is right here. Oh, I can't do that. Why can't I do that? Well, because input automatically yields a string. If I want an int, I need to use the int function. Now there's an int function, there's a float function, there's a bool function. If you want to force the user to use a specific data type with an input, you need to wrap that input in that specific function. Int, float, bool, whatever. And that way it's going to force it. And the benefit of that is integers allow us to do things that strings don't, like math, for example. Same with floats. So we might need that. Booleans allow us to do conditional operators in a different way. So we might need that from the user. So it's important that we recognize. Now, let's run this. Enter your name, enter your age, and it works. It printed the years until retirement. Now, what happens in that same situation if I don't enter a number? So I'm not paying attention. I throw an A in there. Bam, I get a value error. Okay, invalid literal for int with base 10, A. A is not an integer. So we'll deal with this much later in the course, but we would then have to be prepared for that error. So we'd have to do a try and a catch. So we're not going to worry about that right now. So this is how we can add in that user input piece. Okay, it's a really simple function. We just need to know how it operates and how it works with variables and variable types. Again, everything's going to come back to variables. Awesome. All right, time for the challenge. So remember, last week we did the Mad Lib with the hard-coded values, all right? So this time, we're going to take that same Mad Lib, okay, and you can use a different Mad Lib if you want to. That's up to you. But you see all these words that we hard-coded in here? That's clunky. We should rewrite this with user input. So instead of word 1 being hard-coded to Harry, maybe we ask the user for an adjective, and then we ask the user for a noun, and so on. And then we suddenly have an interactive Mad Lib, where you could hand it to your baby brother or sister on your laptop and they get the prompt. It says enter an adjective. They do it. They enter each one. And when they're done, it prints their Mad Lib to the screen. That's great. So that's what I want you to do for the challenge on this lesson. I want you to modify the Mad Lib from last time with the hard-coded values to benefit from user input. And we'll quickly look at a solution to that in the next video. Thank you for watching. Don't forget, if you like the content, like the video, share, subscribe. It's great to know that people want this and people enjoy it. Hit me up in the comments if you have questions. Happy to try to answer them as best that I can. Good luck with the challenge, and we will see you back next time.